Hello everyone. This is R. Sasikumar, Professor, Department of Computer Science and Engineering from RMDEC Engineering College. Today we are going to discuss about sleeping barber problem in operating system. So the problem statement is there is a barber shop with one barber and a number of chairs for waiting customer. Customers arrive at random times and if there is an unavailable chair, they take a seat and wait for the barber to become available. If there are no chairs available, then the customer leaves. When the barber finishes with a customer, he checks if there are any waiting customer. If there are, he begins cutting the hair of the next customer in the queue. If there are no customer waiting, he goes to sleep. This is the problem statement. Okay. So the sleeping problem is a classical synchronous problem in operating system that illustrate how to coordinate multiple processes using the semaphore. It is commonly used to explain inter-process communication and process synchronization, especially in the context of a producer-consumer problem. So the previous video, I have explained that a producer-consumer problem. The same thing will occur in that barber sleeping problem also. So in that problem statement, what is the problem statement means what? We have only one barber and one barber chair and in waiting customer uh, in waiting chairs for customer. So what is the rule of that problem statement means what? If there are no customer, then the barber goes to sleep. So if there are no customer na, then the barber goes to sleep. Whenever a customer arrives, then we have a three constraint. If the barber is asleep, the customer wakes up the barber and gets a haircut. So the start, whenever the customer arrives, the customer has to check whether the barber is sleeping or busy. If the barber is asleep na, then the customer wakes up the barber and gets the haircut. So waiting customer and cutting hair. If the barber is busy, the another constraint, whenever the customer arrives, if the barber is busy and there is an empty waiting chair, then the customer has to wait. So at the time of a new customer arrives, then the barber is busy now. Then the barber has to told, has informed to the new customer, please wait. And empty chair is available, then the customer will occupy that empty chair. This is second constraint. The third constraint, whenever the customer arrives, if all the waiting chairs are full and the barber also busy, then the customer going home leaves. So this is so first rule: if there are no customer, the barber goes to sleep. The second rule: when a customer arrives, we have a three constraint. Whenever the customer arrives, then the customer will check whether the barber is sleeping or not. If the barber is sleeping enough, then the customer wakes up the barber and gets a haircut. Other constraint, if the barber is busy at the time of customer arrives and there is an empty chair, then ask them to sit in that empty chair. So the customer waits in that lobby. Then third constraint, whenever the customer arrives, if all the waiting chairs are full and the barber also busy, then the customer leaves. Then third rule, after finishing a haircut, if no other customers are waiting, again the barber goes to go back to sleep. So what is the main objective of barber sleeping problem? Is what ensure proper synchronization so that the barber and customers operate correctly without any race condition. No two customers occupy the barber chair at the same time, and no customer is missed if a chair is free. So what is the solution of the barber sleeping problem? Is what we have to use three main synchronization primitives. Okay, and waiting customer, the initial value equal to 0, and barber, the initial value also 0, and mutex equal to 1. Okay. This is the pseudocode of Barber sleeping problem. So the semaphore customer count equal to initially 0 and the semaphore barber also equal to 0. So what is the customer? Count the number of waiting customer. So initially 0. What is called a barber? Barber waits up on this customer, signals it. So initial value equal to 0 and the mutex equal to 1. What is the meaning? Means what? It control access to the waiting room chairs. So we also maintain what waiting a counter for the number of customers currently waiting. and n is nothing but what? Total number of chairs in the waiting room. So in integer, free seats equal to n. What is the meaning of n? Means what? A total number of chairs waiting in the room. Sorry, total number of chairs available in that waiting room. So now the pseudocode, so while of true waits for a customer. So down customers, mutex to protect a number of available seat, down seat, and chairs gets free, free seats plus plus. Bring customer for haircut. So now that customer will be occupied the barber chair and release the mutex on the chair and up seats. So one seat will be free. So waiting seat will be free. The barber is ready to cutting the hair also. And customer side, while of true, products seat, so only one customer tried to sit in the chair. If that is the case, down seat. This line should not be here. If free seat is greater than 0, then sitting down. And once the customer occupy that seat now, then free seat will be decremented by 1. So notify the barber, yes, the customer is available and waiting in the lobby. Then the barber will call that customer. So up of customer, release the lock. So up of seat. While in the waiting room, if barber is busy, down of barber, customer is having haircut. So either customer is having haircut and otherwise what customer is waiting in that lobby. If there are no waiting chairs and the barber also busy and the customer leaves. This is the pseudocode of barber sleeping problem. I hope you understand this concept. Thank you.